Okay, complete the proof of the Isosceles triangle theorem. Now the Isosceles triangle theorem states that if two sides of a triangle are congruent, then the two angles opposite the sides are congruent. So here we're given two sides of a triangle are congruent, and we're going to prove the two opposite angles from those sides are congruent, which are the base angles, angle B and C. First step is the given, segment AB congruent to segment AC. Now there isn't really much more we can conclude from this statement, so I'm going to move on to something else. Next thing is going to be this angle A. Angle A is congruent to itself. Now, thing is, what this proof does is it kind of uses the same triangle twice. In other words, we're going to prove that this triangle is congruent to itself using a different order, and then we'll be able to conclude that angle B is congruent to angle C. So angle A is congruent to itself by the reflexive property of congruence. And segment CA is congruent to segment BA by the symmetric property of congruence. And all it's doing is reversing the order of the letters based on statement 1. Statement 1 has segment AB congruent to segment AC. Statement 3 has segment CA congruent to segment BA. Notice it's just reversed order here, and that's what the symmetric property does. Now the next statement, we can go ahead and conclude this statement. We have triangle BAC congruent to triangle CAB. So essentially, it is the same triangle, but the letters are in a different order. You're going the other way around. And that's by the side angle side triangle congruence theorem. Okay, now the reason this all works so far is because these two segments, AB and AC, are congruent to each other. So you can actually kind of create two different triangles going in different orders. And finally, we can conclude angle B is congruent to angle C, and the reason is corresponding parts of congruent triangles are congruent. Okay, so there you have it, a proof of the Isosceles triangle theorem. And it's a rather unusual proof in that you use the same triangle in two different representations, where you have triangle BAC and triangle CAB.